Hello, my name's Clyde Morris and I want to show you a typical GCSE problem which involves a voltage divider where we've got two resistors R1 in series with another resistor R2, and we've got to try and find out the voltage across the second resistor, the voltage across R2, this voltage here V2, and we've got a 9 volt power supply as well. Okay, so how do we go about doing this? Well, the first assumption that we need to make is that the current flowing through the resistors is the same all the way through. And we can make this assumption because the resistors are in series. R1 is in series with R2, so the same current must flow down through the 5K resistor. So we'll just call this current I, and it must be the same current which is flowing down through the second resistor R2, and the same current all the way down to 0 volts. Okay, so it's the same current. And what we can do is we can use Ohm's law for the whole circuit, all right? So Ohm's law for whole circuit, okay, for the whole circuit. As you know, Ohm's law states that voltage is proportional to current, or V is equal to I times R. Right. So for the whole circuit, the voltage is 9 volts. We don't know what the current is, so we'll just leave that as I. But we do know what the resistance is. And because it's a series circuit, what we have to do is we have to sum the resistors. So basically it's 5K plus 10K, which is 15K, all right? So it's I times 15K, all right? The sum of the two resistors, they're in series. So we simply add the 5K to the 10K, and that gives us 15K. All right, so this is all of the values plugged into the Ohm's law equation. And I think what I'm going to do is I'm going to rearrange this to make I the subject. All right, so just rearranging this. Therefore, I is equal to 9 volts over 15K. I'm just going to leave it like that just for now. All right, so I'm going to call this expression number 1. I'll just put it in a box as well. All right, so that's the current flowing through the circuit, and we could evaluate that if we wanted to, but I'll just leave it as it is just for now. Okay, so what I need to do is I need to this time use Ohm's law again, but this time for resistor R2. Okay, Ohm's law for resistor R2. All right. And for resistor R2, we can write V2, because this is the voltage across R2. V2 is equal to I times R2. So this is just Ohm's law for resistor R2. Okay. And let's call this equation number 2. So again, I'll just box this off just like this. Okay, so this is equation number 2. All right, so we've got two equations now. An equation number 1, which is for the current, okay, and then the second equation in terms of V2, which is what we're trying to find. We're trying to find V2. Now, we know what R2 is. So I'll tell you what, let's just tidy this up a bit. So this is going to be I times 10K, okay, I times 10K, because that's what V2 is. Okay, so what I'm going to do now, so I'll call this number 3. Okay, so what I'm going to do now is I need to substitute for the current in this equation here. In other words, I need to substitute 1 into equation 3. All right, so that's what I need to do next. Substitute 1 in 3. And when I do that, what I find is V2, which is what I'm trying to find. V2 is equal to I. Now my I comes from equation 1, and my I is 9 volts over 15k. All right, so that's 9 over 15k. Okay, 9 volts over 15k. That's the I part of it, and the R2 is 10k. All right, that's the R2 part of it from equation number 2. So it's that times 10k. All right, so all I need to do now is to try and tidy up this expression for V2. So the first thing I notice is that we've got k's top and bottom, so I'm going to cancel those k's like that. And this is going to leave me with 9 times 10 volts over 15k. Sorry, over 15, we've cancelled out the k's. Excuse me. And when we tidy that up, that leaves us with 90 over 15 volts. And when we finally tidy that up, we end up with V2 being equal to 6 volts. Okay. All right, so that's how we use the voltage divider to find out the voltage across the lower resistor, across the resistor R2. You could go on to work out what the voltage is across the resistor R1. So let's have a look at that briefly. It's a relatively easy task now we've got this far. Let's just do a quick redraw of the circuit. Okay, so we've got R1, which is 5k. Then we've got another resistor here, R2, which is equal to 10k. We've determined that the voltage across this resistor here is 6 volts. We have 9 volts across the whole lot, right? 9 volts across the whole lot. That's from the supply. And we can represent it in that way. So if we had to find V1, which is the voltage across resistor R1, well, hopefully you can see that V1 must be 3 volts, because in order to make 9, you'd have to have 6, plus you would need 3 volts for V2, and the two of them would sum to 9 volts. So just looking at it, we can see that V1 must be 9 volts. Or the other way you can think of it, 9 volts must be equal to 6 plus V1. So once we rearrange that, we can see that V1 must be equal to 9 minus 6, which is 3 volts. Okay, well, that ends this tutorial on voltage dividers. I hope you found it useful, and thank you for watching. Thank you.